I would say that space dependency is growing exponentially. With that, there's actually a proliferation of space activity that is now starting to go on. And I would say that space exploration, innovation, and through the use of on-orbit and lunar manufacturing capabilities and opportunities are really on the horizon, things that we're thinking about. We're thinking more about 3D printing in space. We're talking about, and you're seeing it today, civilian space travel. And we're seeing today the growing popularity and opportunities that are involved with civilian space travel. If you have enough money and you are so inclined, now you can take a ride on a rocket. And so that's another interesting avenue. It's just going to make people more excited about space exploration and innovation. I would say that a few of the heroes that I've watched on being innovators in space are Sir Richard Branson, Elon Musk, and Jeff Bezos. And those are just a few that are more well known, but they have taken their ideas into space activity, exploring, innovating, and watch them and people like them for new ideas about where we're going to be going in space. I wish years ago I would have had sort of some insight perhaps into the commercial intensification that has happened. I was so much involved with the military and with large satellites that cost lots of money, putting them into space primarily for national security considerations, and then the growing considerations of satellite communications, both military and government and industry. The government and national security dependence in those years has just grown so magnificently and exponentially. And industry, I find, and commercial enterprises, unlike government, is much more innovative. They are much quicker at developing space capabilities. They're willing to take a risk and fail and go ahead with another advantage. I find that government and national security dependence is growing in this time, in this era. And I especially look to industry and the commercialization aspects of the fact that they in industry are willing to take chances. They're very innovative in their thought. They're fast in developing areas of space exploration and capabilities. And they're also willing to take some risk. Government tends to be risk averse. We tend to fail at times, and when we fail, we go into a lengthy process of exploring, why did we fail? What do we need to do? And years pass. Industry just gets on with it and gets in there and makes the investment. And so that's why I think we are so inclined to lead so much more toward industry for the future of space. So one of the big considerations I have today is the Kessler effect. And that is when space debris, in low Earth orbit especially, because objects there are traveling at 17,000 miles per hour. And if one of those objects collides with another, or if there's space junk or space debris that is in that orbit that they hit, it causes more debris from a collision and an explosion, if you will, that then proliferates that area of that orbital plane. And so this can trigger then a cascading effect of constantly colliding debris of the on-orbit objects. And so this can become very, very concerning for all of us for obvious reasons. Lots of money is spent on those space objects, and when they start colliding with each other, and it's a cascading effect, you can have a large cloud of space debris that is traveling in that orbital plane, which is very dangerous, even for International Space Station or shuttle or any types of activity that is going into that orbital plane, which is where we operate so much now with humans. Telemedicine became a very important part. And it wasn't something we thought of. It was just a spin-off that came from a primary mission that could be used in a different way. I would also say with navigational satellites. For military purposes, we have turned those into and used them very accurately for targeting. And I think we, unfortunately, watch a lot of video on our news these days of activity, and it comes from space, with drones, with communications, with targeting. We all watch, and there's a cursor put on a target, and it's eliminated. So that's another area that was a spin-off of something that was developed as a navigation system. So these secondary missions areas that were unimaginable or that we didn't think about or can emerge from any kind of primary mission area. And I think we're going to see lots more of that as time goes on. I would also say that another area that I did not imagine that has developed so much is the interest in low Earth orbits. And the LEO satellites that are now proliferating. Thousands of satellites are now being put up. And as I mentioned earlier, the multi-orbit cross-links that are happening. Not just cross-link communications in one orbital plane, but cross-link connectivity between the various orbital planes. That's a huge step forward that I didn't imagine would happen a while back. I have quite a long list of concerns and considerations for the future. And this comes from my 50 years or so of working in the space related industry. First and foremost, I think today on my mind is the intersection of cybersecurity and space. And frankly, those are the fourth and fifth operational domains that we now are working in. The others being land, sea, air, and now we have the fourth operational domain of space, and newly recognized as the fifth operational domain, cyberspace. So we have this interesting intersection of space and cyberspace. And we launched a lot of satellites into orbit over the years with no cybersecurity protection. And so if someone could get into the data stream and into the way you're communicating with that satellite, they could disrupt that, they could turn the satellite off, they could change the parameters of the satellite or manipulate it in some way that you don't want. So the cybersecurity aspects of space operations is very critical and a growing concern. As a matter of fact, we're starting to refer to it in some circles as space cyber. And to make it distinguishable, all one word with a capital S and a capital C to make it stand out. It's something that we're considering now heavily. The other thing that has emerged in our world today, just really and grown in consideration, is artificial intelligence. And probably a year ago, we weren't talking about artificial intelligence or AI much at all. Now it's in every boardroom, every consideration. Everybody is talking about artificial intelligence. It can be very beneficial to your operation, but it can also pose huge vulnerabilities in your operation and the information that you're providing and gaining from it could be misinformation or disinformation that changes everything. So that's going to be a huge consideration, not only in cyberspace, but also in space operations. Another area that is really growing out there, and we thought it might be a little further down the line, but is quantum computing, where everything is going to be speeded up so much more faster. As a matter of fact, speeds of computers may reach the point where no encryption network will be good enough for a quantum computer to break that encryption algorithm. That's scary. Several other considerations for the future are the opportunities that come from space manufacturing, particularly by use of a space colony on our own moon, where we can build things there with the benefits of the weightlessness of space, but also being able to take other debris that we've captured from space of objects that had been used in the past, but now we bring those together and use those metal and other capabilities to build something new without bringing it all the way down to Earth and then fighting gravitational force to get things back into space. Space mining is another area that we can look to for the future for tremendous benefit. We might be able to mine on asteroids for materials that we need here on Earth, or we may find other raw materials that we are not even familiar with that could bring great benefit to the future of our nation. One last consideration that I have is the fact that we hope this doesn't happen, but that our Earth is hit by some asteroid or meteor in the future that would cause catastrophic danger to us, with either the collision itself or putting us off orbit. That would be that massive that could, when you talk about the potential for climate change, that could be very, very serious with a collision with our planet. I've had an exciting career that's lasted over 50 years. I've had the opportunity of working with our government for our national security, with government systems that were put into space at huge taxpayer cost. But then I've also seen that transition into the commercial world today, where industry sees the great benefits that come from operations in space.